Okay, so before I show you how to complete the square, I want to first talk to you about what we call the nature of quadratic roots. So this means when you solve a quadratic equation, the kinds of numbers you get reflect what the graph is actually going to look like. So these really break down into three categories. So the first one I want to talk about is when you get real unequal roots. So this could look like a variety of different things. It could be something as basic as just two plain old whole numbers, like -3 and 5, or it could be something really messy, like 2 plus or minus 6 rad 7. Okay, so again, as long as you see that plus minus there, that indicates that there are two roots, which that leads us to that whole unequal idea. So 2 plus 6 rad 7 and 2 minus 6 rad 7 are different roots. When we have this situation, we're going to end up with a parabola that hits the x-axis 2 times. Now I'm just sketching one in. These don't necessarily reflect the roots I wrote over here. It could also be an upside down parabola as long as it's hitting 2 times. So that means anytime you have real unequal roots, your graph should have 2 x-intercepts. And we should be able to say that without looking at the graph, even though, of course, you can look at the graph in your calculator. Okay, so then if you have real equal roots, so we don't have as many options here, that means you have to actually get something like 2 and 2, or negative rad 6 and negative rad 6. Again, they don't have to be pretty, but it means that you get the exact same root 2 times. So these kinds of graphs have to hit the x-axis only 1 time. So it's just going to touch it and turn back around. Like before, this could also be an upside down parabola. It doesn't necessarily have to be a right side up one as long as we see that it hits the graph only once. So any quadratic equation with real equal roots has just 1 x-intercept. Okay, and then finally, if we get roots that are complex. What is a complex again? That's any number that's a combination of a real number and an imaginary number. So it could be that we solve using completing the square and get something like 3 plus or minus 4i. Okay, that's a combination of a real number and an imaginary number, which is why it's complex. We could also get something a little messier, like -2 plus or minus 3i radical 5. Anything with an I in it falls into the category of complex numbers, and in this case, these graphs actually do not hit the x-axis at all because they do not have real roots, so we can't actually graph them on our regular xy axis that we're used to. So these types of equations have 0 x-intercepts. Okay, so that's a basic summary of all the different kinds of roots you can get and what's reflected in their graph. So when we say the nature of roots, we're talking about, are they real and unequal? Are they real and equal? Are they complex? Okay, so now let's go ahead and actually complete the square, and then we can talk about how many x-intercepts those equations would have. Okay, so I have x squared plus 24 equals 8x. So the first thing that I usually do is I set my equation equal to 0, just like when I'm factoring. So I'm going to move my 8x over. So putting all my terms in order, I now have x squared minus 8x plus 24. You want to make sure you always have your quadratic equation in order, because otherwise any attempt that you try to make, whether it's factoring or completely square, you're going to get the wrong answer. Okay, so now I've got everything set equal to 0. My next little step is I actually always need to get my c, which is just my number without variable. I need to get that on the other side. So I'm going to subtract 24 on both sides. Okay, so now I have x squared minus 8x equals negative 24. Okay, so that's kind of all of the setup. At this point, if we had a coefficient in front of my x squared term that wasn't a 1, in this case there's nothing here, so we know this is technically a 1. If that was anything else, we would have to divide out by that number, but in this case, we don't have to worry about that, so we're going to skip to the next step. Okay, so now I'm ready to take my b, that means my coefficient with my x, so which is typically my middle term. I pull that off to the side, divide it by 2, and square it. This number that I get from doing this is going to get added to both sides of my equation. So I'm going to rewrite what I just had, except now I know that if I divide 8 by 2 and square it, I'm going to get 16, so I'm going to add a 16 on both sides of what I already had. I'm adding it to both sides because if I want to keep the equation the same and I'm going to bring in something new, I have to do it on both sides. Okay, so now I'm here. This is kind of the completing the square step. I've just turned the left side of my equation into what we call a perfect square binomial. So if I was to sit and actually do MAM on this, what I'm about to write is what I would get as an answer. I let you guys, though, skip to sort of the actual binomial. I don't make you go through MAM because we know how this is going to work every time. So we can take our variable, our sign, and the answer that we got when we divided by 2 but before we squared, which in my case is a 4. So this is condensing that trinomial. Again, if I was to do MAM, I would get x minus 4, which can just be written as x minus 4 squared. I'm not going to make you guys do all that because this is how it's going to work every time. Negative 24 plus 16, negative 8. Okay, so now I'm just solving from here. So to undo the squared, I'm square rooting both sides. So the square root and the square just undo each other, and I'm left with just plain old x minus 4. Over here, the square root of negative 8, first of all, because it's negative, I'm pulling out an I. 8 can be simplified. So in this situation, you'd want to pull 8 over to the side really quick if you can't do this in your head and break it down. So in this situation, I'm going to have 2 times 2 times 2, so there's going to be a 2 coming out and a 2 left over. So this, if you guys don't mind, I'm going to go up here because I'm running out of space, is really x minus 4 equals, remember we always have to have a plus or minus, 2i, because we pulled out a 2, square root 2. Okay, so that's the simplified version of what we just had, that I square root 8. The plus minus always goes in front because I need 2 answers. I pulled out a 2, that's where I got this 2, and I leave a 2 inside. Okay, so I'm almost done. All I have to do now is add a 4 to both sides. And I get that x is equal to, I usually put my real number first. You don't have to do it that way, plus or minus 2i rad 2. If you want to write it in the other order, that's fine with me. This is my final answer. And if I was asked the follow-up question of how many x-intercepts this would have, because I have complex roots, when I see that I know my roots are complex, this would actually have no x-intercepts. So no x-intercepts. So if you were to have to sketch the graph of this, you would expect it to not hit the x-axis at all. Okay, so there's one example. We'll do one more. Okay, different quadratic equation. My setup's a little bit different this time. Now remember, usually we set the equation equal to 0, but then we're going to end up having to move the 8 over to the right-hand side anyway, so I'm actually going to leave this. I'm skipping that step because if I move 8 over by making it negative, I'm going to then just bring it back. So I'm going to leave it right here. At this point, I do have a lead coefficient of that's not just 1, so I have to divide everybody by 5. Okay, this will sometimes leave me with fractions. I know that's annoying, but it's okay. I'm just going to leave that as 6/5, and on the other side I have 8/5. Okay, so now I'm ready to do that step where I'm going to pull my b, or my coefficient of the term with just an x. I'm going to pull this over to the side, divide it by 2, which means I'm actually dividing a fraction by 2, and squaring it. In this situation, I actually want to write down what this answer comes out to in the parentheses, because remember, we need it later. So if you go ahead in your calculator and do 6 over 5 divided by 2, you should get 3/5 when you math bracket. And then remember we still have to square. That should just give me 9 over 25. So this is the number that I'm going to be adding on both sides. So I'm going to go ahead and write out what I had before. And now I'm adding in that new number of 9 over 25. I know this is a little annoying because I have a lot of fractions, but remember, a lot of times it does get much neater in the end, so just kind of stick through it. So now I'm adding that 9 over 25 again. Okay, so at this point, on the left-hand side, I'm doing that whole squared binomial thing that I did before. So in this case, I'm taking x, the subtraction sign, and remember what I said, we need the number that we got when we divided by 2, but before we squared. That's why I saved that 3/5. So this binomial is going to be x minus 3/5 squared. And then on the right-hand side, I just need to clean that up. So I'm adding 8/5 and 9/25. If you add these in the calculator and math frac your answer, like you always should be doing, we get 49 over 25. Okay, so now I'm going ahead and square rooting both sides because I'm undoing that square. So this is going to just leave x minus 3/5. This, actually, remember, you can either do this in your calculator or keep in mind that a square root can be broken up. So 49 and 25 are both perfect squares, so that I can just actually make this plus or minus 7 over 5. So that's actually not so bad. Now I'm ready to add 3/5 to both sides. Now, on that last example, we just added it over and sort of wrote our answer out as one big expression. That was because we had a radical and an I, and it wasn't going to come out nice. In this case, I really can add 7/5 and 3/5 pretty nicely. Keep in mind, though, that you're really adding 7/5 and 2/5 to get one answer, and then negative 7/5 and 2/5 to get your other answer because of that plus minus. So 7/5 plus 2/5 should give you 9/5. That's one of your answers. And negative 7/5 plus 2/5 should give you -1. Okay, so I get two distinctly different answers, 9/5 and -1, which you can write in a solution set if you'd like. And again, we'll just talk about if you're asked that follow-up question of how many x-intercepts this graph would have. In this case, because I have two real unequal roots, I would have 2 x-intercepts. Okay, and that's it.